Very good morning, students. In the chapter time series, we had come across in our previous classes initial and basic concepts of time series and components of time series. In that, first component of time series was trend or a secular trend. In terms of methods of measuring secular trend, we had seen in the last video class that there are 4 methods prescribed in our syllabus in measuring secular trend. Which were those? First one was graphical method, second one was semi-averages method, and the third one was moving averages method, and the last one is least squares method. In that, first 3 methods we had already learnt. Their merits and demerits also we had seen. All those demerits which we have observed in first 3 methods, we will be able to rectify in the last method, which is least squares method. Let us see what way least squares method has to be executed. Least squares method. This one is a mathematical method of measuring trend, which is equal to of the type y is equal to f of x. All the 3 previous methods were not completely mathematical. They were partially mathematical. First one, graphical method, at least it was not at all a mathematical one. All the given values we used to plot on the graph and one imaginary trend line we used to observe. And secondly, semi-averages method, it was taken the given data into 2 equal parts. If it is even number, then exactly 2 equal parts. Otherwise, if it is given odd numbers, number of observations in terms of odd number, if it is given, one value used to be ignored, middle one, and the rest 2 parts were used to calculate averages. And then in moving averages method also, we had already seen it was odd yearly or even yearly moving averages, and most of the times or all the times we were not able to get initial and end time points, the trend values. So all these demerits which we had will come over in least squares method. This is purely a mathematical or completely mathematical method. Y is equal to f of x in the sense, already, y is a function of x. This function of x may be in many ways. We have been prescribed in our syllabus 3 such function of x in terms of y to solve under least squares method. First one is linear equation or a straight line equation. This is nothing but what you have learnt in mathematics, slope intercept form, which is of the kind y is equal to a plus bx. Y is given values and x is time points in terms of years. Usually it will be given, for example, 2000, 2001, 2002, 2003 till 2010 may be given the time values, and given values may be of import, export, production or anything of that kind. Those will be interpreted as y. And a and b are constants which are to be determined. Second type is quadratic, or it will be called as parabolic or second degree equation, which is of the kind y is equal to a plus bx. The same equation y is equal to a plus bx in straight line equation which we have seen is present here, a plus bx. In addition, here plus cx square. Since it is quadratic or a second degree equation, x to the power 2 appears. Here straight line equation was first degree equation because x to the power 1 we were landing here. Here it is nothing but a into x to the power 0, which is 1. That's why a alone we had written. And here plus b x to the power 1. This is first degree equation. And here it is second degree equation. That's why y is equal to a plus bx plus cx square is being considered. This is second type of equations which have been prescribed. And the last one, exponential or logarithmic equation. Once when we are calling exponential equation, it is of the form y is equal to ab to the power x. Observe carefully, to the power x what we have seen, it is not whole to the power for a and b, it is just b to the power x. Carefully it has to be observed. And this equation, by applying logarithm, if we have to write, you know already logarithmic equations how to be written. Here if you apply y log, then it will become log y, and here log a, and once when multiplication is there in terms of log, you will be taking plus all these plus x log b it would become. That means log y is equal to log a plus x log b. These are the three methods which have been prescribed, which are of very significant importance in terms of examination. Usually 10-mark questions and even 5-mark questions will be asked based on this particular concept. We can say in section D of our question paper, one fixed question for 10 marks we are going to receive. So try to understand properly, thoroughly the concept and execute it properly. We shall see one by one all these methods, how to execute numerical problems and how to find out trend values using all these three methods. Let us consider first method of least squares, which is linear or straight line equation method. We know already what is straight line or linear equation. Y is equal to a plus bx. I have mentioned already where a and b are constants and those are to be determined using following normal equations. In this equation, x values are time points and y values are the given values of a particular phenomenon according to x time points. For example, x may be the time points as I have mentioned already, 2000 to 2010, and y may be import, export, production, or the crop, how much tons, or how much amount it has been produced. All those kinds of values may be y. In this equation, a and b are the constants. For given values, for given value of a time series, these a and b are to be determined. To determine these a and b values, we use these normal equations, which are exactly derived from the main equation which we have given as equation 1. Let us concentrate here equation 2 and equation 3 as normal equations, how we will be able to get from this particular base equation. Here for the given linear equation y is equal to a plus bx, let us apply summation. What will it become if I apply sum for this y? It will become summation of y. Since it is variable y, it will become sum of y, or y is being written under the summation. Once when variables are there, they will be under summation. Once when constant will be present, that will be away from summation. You know already all these kind of basic mathematical concepts. So after applying summation, this will become summation of y equal to a is there as a constant. Summation, if you apply sum of a particular constant a. Sum, how many times you will be making summation? That means sum of I is equal to 1 to n, in terms of sum of I is equal to 1 to 5, 1 to 7, something of that kind. When you have practically, it will become n times that particular constant, because no variable is present over here, only a constant is present. If you apply summation, how many times sum, how many times you are adding, those many times multiplied by that particular constant, the result will be. So that usually n is being considered as number of values given in the time series. When we are solving in numericals, we may be specifically observing how many values are given. Once when generally we are speaking, we will be taking it as n. So summation of a will become, summation we are taking n times, so that n multiplied by a. Here it has been written n multiplied by a. Then plus as it is, b as the constant. See here, bx is the combination of both constant and a variable. So whichever the constant is there, that will come out of the summation, and whichever is variable, that will remain under summation. So here b is a constant, so I'll be taking b outside and summation of x as it is. So observe once again properly. After applying sum, what will become? Summation of y, and then summation of a particular constant, only constant when it is there, n times that particular constant it will be, so that na plus b as it is, because it is constant we have kept it outside and variable is there, this has been written under summation of x. Let us call this equation to be second equation. And the third one, this normal equation, how we are going to get is summation of x is being applied to the original equation or to the base equation. Here in this normal equation, to this base equation we had applied only summation, and here we are applying summation of x. Here y is already there. When you apply summation of x, both x and y will be variables, so that under summation they are being written summation of x, y equal to a is a constant, so it is kept outside, and summation of x we are multiplying, so summation of x, plus b constant which is kept outside, and summation of x to be applied over here, already x is there, summation of x into x it will become, so that summation of x square. This will be the third equation. So these second and third equations are called as normal equations, which are used to find out both the constants a and b. Suppose if sum of x is equal to 0 in the given numerical problem, if sum of x equal to 0, what will be obtained by both these normal equations? We have to observe now. If sum of x equal to 0, what will happen in this particular equation? This sum of x is equal to 0, so 0 multiplied by b, this term becomes 0. Only remaining is summation of y is equal to n into a. So that a has to be determined. A as it is, here only we can keep a is equal to summation of y divided by n. So a can be obtained in case of sum of x equal to 0 as summation of y divided by n. In the similar way, we have written here, if sum of x equal to 0, then first equation implies a is equal to summation of y divided by n. Accordingly, what will happen, or what we will be able to derive from this particular normal equation. Here sum of x is equal to 0. So this term entirely has gone to 0. And b we need to determine. So b is equal to summation of xy divided by sum of x square. That's what has been written here. Second, normal equation will imply b is equal to summation of x, y divided by this x square. Here 1 and 2 what I have written determines both normal equations. Actually 2 and 3 is written here as the equations. Don't get confused. 1 means the base equation I have written and 2 and 3 means these two are the normal equations. That's why I have mentioned 1 and 2. Don't get confused with this. 1 and 2 in the sense I have taken as first and second normal equations. So what is our major motto? A and B both are constants. They are to be determined. They can be determined in this way. For a given x and y values as normal, numerical problems, then in this particular fashion we can execute and get A and B values. After getting A and B values, what is to be done is we need to substitute those A and B determined values over here, and x time points at least we will be knowing. X values will be given and y values also will be given. If at all y as import, export or any such concept at a particular x value, if it is to be determined, for example 2000 to 2010 may be given the values, 2012 may be asked to estimate. At that time 2012 value we can substitute over here as x value. A and B values we will be knowing constants already. So future trend also can be determined in terms of y using a given equation. So this is what is a particular concept. We have learned now first equation, linear or a straight line equation. Similarly, quadratic, parabolic or second degree equation, and third one, exponential or logarithmic equation also we need to learn. First, basically a mathematical model how it is, and then accordingly numerical problems are also to be solved. As I have mentioned, numerical examples are of 10 marks. Concentrate properly and learn. And equally, practice is required. Go through all the concepts of time series so far we have learnt, and method of least squares also in the text. Thoroughly you can go through whatever I have explained is there in the text. Thoroughly go through and understand it properly. In the next video class we shall consider numerical problems based on linear or straight line equations. Stay home, stay safe. Thank you so much.